Everyone, and welcome back to my online teaching platform. Still on differentiation. We are still on differentiation. So we have a question here or a function here, and we have to find its derivative. So we have a function y is equal to a fraction with a numerator 10 and a denominator 2x squared plus 1, or in bracket raised to the power 5. And we have to find dy dx. Now you can see that this function is in two forms. We have the numerator and that of the denominator. We have a numerator and that of what? A denominator. So we can consider this function as a rational function since the denominator is not equal to 0. Alright. Now we can use two methods to differentiate this particular function. I'll start with the quotient rule. I'll start with the quotient rule. Then, when I'm done with the quotient rule, we also use the chain rule as the second method. All right, so let's start with. So let us put down our quotient rule as we discussed in one of the previous videos. So we have our dy dx is equal to v du dx minus u dv dx all divided by v squared. All right. Now, which of the expressions in the given function is our u? That's what we are supposed to know. And which of them is our v? So the numerator of the given function becomes our u. So this is the u that we are talking about. So this is our u, and the whole of this becomes our v. All right. So let us write down the various components. So we have our u to be equal to 10. This implies that our du dx will be equal to 0 since 10 is a constant. Derivative of any constant is equal to 0. Right, so let us take our v and also find its derivative. We know our v to be equal to, our v is equal to 2x squared plus 1 in bracket raised to the power 5. So we need to find our dv dx as well. So our dv dx will be equal to, so we can apply the chain rule over here. The shortcut form of differentiating using the chain rule. So we bring down the power, which is 5. Then we bring the same thing again, 2x squared plus 1 in bracket, and the power will be reduced by 1. Then everything multiplying the derivative of the function in the bracket. So the derivative of 2x squared plus 1 will give us 4x. So let us multiply, let us simplify. So we are going to get 4 times 5. So we are going to get 20. Then there's x multiplying the 4. So it becomes 20x. Then open bracket, we have our 2x squared plus 1 inside the bracket. We close the bracket nicely. Then having an exponent of 4. All right. So this becomes our dv dx. So we can now plug in the various components into the formula. So we have our dy dx being equal to v du dx. So we have to bring back the original function of v. So our v, we know our v to be 2x squared plus 1 in bracket having a power of 5. And it's going to multiply the derivative of the u. And the u, we had it to be 0. All right, du dx is 0. Then minus, to now bring your u, which is positive 10, multiply the derivative of the v. So dv dx, we had 20x multiplying 2x squared plus 1, all in bracket having a power of 4. All right. Then everything divided by the v squared, and we know our v to be 2x squared plus 1 having a power of 5, then all squared. All right. Let's continue to work on it. So we are going to get our dy dx to be equal to, now let us work, you could start 2x squared plus 1 to the power 5. Multiply 0, give us 0. So everything becomes 0. That's the first part of the numerator. Then minus, now we have 10, negative 10, but because we have already indicated a negative, so let us take it to be 10. So 10 times 20x will give us 200x, right? So we have 200x over here. Multiplying 2x squared plus 1 in bracket raised to the power 4. So everything divided by, we have 2x squared plus 1 having a power of 5, all raised to the power of 2. So the powers will multiply each other. So we are going to get 2x squared plus 1 raised to the power 10. All right. So we continue to simplify. So we are going to get 0 minus the expression after the negative sign will give us negative of that statement. So we are going to get negative 200x multiplying 2x squared plus 1 in bracket having an exponent of 4 and divided by 2x squared plus 1 in bracket having a power of 10. All right. Now you can see that when you take 2x, one of the factors of the numerator, when you take 2x squared plus 1 having a power of 4, you will see that the denominator also has 2x squared plus 1 as a denominator. But the only difference is that they don't have the same power, but the bases are the same. So we can apply one of the laws of indices. So it's going to give us, we are going to get for negative 200x multiplying 2x power 2 plus 1, then it's going to be power 4 minus power 10 because they are divided. So it's going to be the power of the 1 in the numerator minus the power of the 1 in the denominator. So it's going to be 4 minus the power 10. All right. So this will give us negative 200x multiplying 2x squared plus 1 in bracket raised to the power negative 6. All right. So this becomes the answer, but you can rewrite it so that we get it as a fraction. So now our negative 200x multiplying 1 divided by, so I'm changing the power to positive. So it's going to be 1 divided by 2x squared plus 1 raised to the power positive 6. So at the end, we can now multiply the 1 of the fraction, which is the numerator of the fraction, by the negative 200x. So that will give us negative 200x, then divided by 2x squared plus 1, having an exponent of 6. So this becomes our dy dx. All right. Now let us use the order rule. We are going to use the chain rule straightforward. We are not going to use the quotient rule and see whether we'll be getting the same answer. So the original function given was y is equal to 10 divided by 2x squared plus 1 having an exponent of 5. All right. So we are going to differentiate using a shortcut. All right. So I can rewrite this as y is equal to 10 multiplying 1 divided by 2x squared plus 1 in bracket having a power of 5. All right. So I want to rewrite it in such a way that I'm not going to get a fraction again. So this becomes 10 times 2x squared plus 1 in bracket. Now, since interchanging the position of the numerator and that of the denominator, we are going to get that power becomes negative. The sign of the power changes to negative. All right, so here will be power 5. All right, so we now have it as 10 times 2x squared plus 1 in bracket having an exponent of what? 5. All right, so now let us differentiate this. So we can now differentiate it using the chain rule. So we are going to get our dy dx to be equal to bring down the power to multiply. So we have negative 5 multiplying 10. Now we open our bracket to maintain the same thing, 2x squared plus 1. Then you reduce the power by 1. So you have negative 5 already minus 1. Then everything multiplying the derivative of the expression in the bracket. So when you differentiate 2x squared plus 1, you're getting 4x. All right. So now simply we are going to get negative 50 times 4x multiplying 2x squared plus 1 in bracket having an exponent of negative 6. Now we have negative 50 times 4x. So we are going to get negative 200x multiplying 2x squared plus 1 raised to the power negative 6. All right. So we'll be having it in the form negative 200x multiplying 1 out of 2x squared plus 1. Then the sign changes to positive. All right. So we'll be having it in this form. So now the numerator of the fraction, which is 1, will now multiply the negative 200x. So that will give us negative 200x divided by 2x squared plus 1 having an exponent of 6. All right. So